Yeah, hello dear students. You are welcome to yet another session called Mathematics for Senior High School. So we are going to look at change of subject. We are going to change subject. Now I don't mean we are going to change subject as in from core mathematics to integrated science. No. It is a topic we are going to discuss. Okay, so change of subject, right? I believe we are ready. Yeah, though we are not changing the subject, it is still core mathematics, but we are going to change the subject in core mathematics. Alright, so let's proceed. Okay, so let's look at the session outline and objectives. So what do we expect to achieve by the end of this lesson? So by the end of the lesson, you should be able to make different variables a subject in a given equation, and then substitute known values of variables in an equation to find an unknown value or variable, right? So that is what we are going to basically talk about in this lesson, right? So it is a pretty simple lesson, a pretty simple topic. I believe you are going to grasp it so easily and quick, right? I believe you are together with me. Alright, so all said and done, let's begin the journey, right? Okay, so change of subject. Now, what does it mean for us to say change of subject in mathematics? Okay, I believe you have some fair idea or some knowledge on linear equations, right? Yeah, so change of subject is just an extension of linear equation, or let me say we perform change of subject when we have an equation, when we have a linear equation, right? And I believe you know that with a linear equation you have two expressions, right? You have one expression on the left hand side and another on the right hand side, right? So let's take this expression as an example. So you have y is equal to mx plus c, right? So this is a typical linear equation, right? So you have one expression on the left hand side, that is y, and then another expression on the right hand side, that is mx plus c, right? So this is a linear equation, a typical linear equation, right? Now we said change of subject. So what do we mean by the word subject? The word subject is simply it is what is being defined by another expression, right? It is a variable that is being defined by a mathematical expression, right? So we have y is equal to mx plus c. Right, so this y is standing alone, right? And then it is equal to mx plus c. So the mx plus c, that is the expression on the right hand side. It is just giving us the definition of what y is, right? And this is the equation of a line. I believe you know, right? So this is telling us that for you to get the y component of the equation of a line, it is given by the gradient times the x value plus the y intercept, right? So I believe you are familiar with this concept, right? Yeah, so y is equal to mx plus c. The mx plus c here is just defining what y is, right? And when we talk of subject, you see, based on your knowledge on English language, when we say this is the subject of a sentence, what are we talking about? We are saying that it is what the sentence is expressing, or it is what the sentence is talking about or referring to, right? So here y is equal to mx plus c. So the expression here is just showing us what y is, right? But then there are times that will be required to change this subject, meaning that you see we have other variables. We have, apart from y, which is the original subject now, we have other variables like m, like x, and then we have the c. So we can be asked to now change this subject. it is more of like you have a government, right? A government, and then let's say at the end of the tenure of office of that government, there is an election to either maintain the government or to change, right? And then in some instances there happens to be a change in government, right? So here it means that here Y was more of the government in power, but then we want to change Y and then bring, let's say, M or X or C back on the seat, or we want to replace Y and then bring, let's say, X to occupy the seat now, right? So that is more of change of subject. So I just want to give you a general overview of what change of subject is all about, right? So change of subject simply means you making another variable stand alone. You see here Y is standing alone, right? So change of subject saying that, for instance, let's make X stand alone instead of the Y. So let's rearrange the equation such that instead of letting Y stand alone, we will let's say X stand alone, right? So when after we are through with this topic, you would understand why you are saying this X is equal to Y minus C all over M, right? So when we make X the subject here, we are going to arrive at this solution, that X is equal to Y minus C all over M, right? So that is simply what change of subject is all about, right? So let's quickly run through the lesson and look at how change of subject is done practically. Alright, I believe you're enjoying the lesson. Okay, let's proceed. Okay, so what is the process involved in changing the subject? Alright, so like the example that I gave, if you want to change the government of a democratic state, the process involved is what is the general election. Alright, yes, so that is how we change the subject in terms of politics, or in terms of government or governance. So what about mathematically? How do we change the subject, right? So these are the steps or the guidelines we are supposed to abide by to help us arrive at our successful change of subject. So the first point is resolve all brackets, fractions, squares and square roots, right? So because you want the variable to stand alone, we have to, as much as possible, clear anything that is attached to this variable. We have to clear all things that are attached to the variable so that it will remain alone, it will stand on its own, right? So that is what we do here. We remove all brackets, all fractions, all squares and square roots. We will be looking at how to deal with how to resolve fractions, how to eliminate squares and square roots later in the lesson, right? But then that is the first and foremost thing that you have to do. So remove all brackets, fractions, squares, square roots. So let's look at this example. So we have this expression here. We have a into bracket x plus b, right, is equal to b into bracket x plus c, and we have to make x the subject in this equation, right? So the first thing, as we are seeing here, is we have to resolve all brackets, fractions, squares and square roots. So here we have in a bracket here, right? So the first thing we have to do is we have to expand this bracket. You have to expand this bracket. So when you expand, you are going to get ax plus ab is equal to bx plus bc, right? So with bracket, whatever variable or whatever term that is outside the bracket is going to multiply every individual term in the bracket, right? So it means here we have a into bracket x plus b. So in expanding or in distributing a over x and b, we are going to take a and then multiply by b, so we multiply by x, and then we also multiply the a by this b, right? So we are going to get a times x, which is ax, plus a times b, which is what, ab. When we come here, we are going to apply the same concept. So b will multiply c, b will multiply x, at the same time multiply c. So we are going to have bx plus bc, right? So that is the first thing. So once you encounter any bracket, the first thing you have to do is what? Is to expand that bracket, right? So that you sort of, release any variable that is in the cage. So the bracket serves as a cage, right? So you want to release them out of that cage or out of that prison. So that is it. Now the second point is group the required term or terms at one side of the equation, right? So here we are told to make x the subject in this equation, right? So making x the subject, now you can realize that we have x here, we have x here too, right? So the x's they are scattered, right? But because we want to make x the subject, as much as possible we are supposed to group all expressions or all terms that contain the potential subject at one side, right? Yeah, so that is what we are going to do. So we are going to group all the all the expressions or terms that contain our x component, right? So here we have ax plus ab is equal to bx plus bc, right? So what we do is that we are going to bring this whole expression dx to the left hand side so that it will come and join the ax, right? Because they are like terms, right? They are like in terms of the variable in question, or let me say the potential subject here, right? So we are going to have ax minus bx. I believe whenever you are crossing over the equal to sign, you always change the original sign or operation, right? So here we have bx, it is positive, right? So the moment it crosses from the right side of the equation to the left side of the equation, it becomes negative. That is why you are seeing ax minus bx, right? Likewise, we are supposed to deport, or let me say you are supposed to take away all terms that do not contain the potential subject to the other side of the equation. So we have to eliminate, or you have to sort of expel them to the other side of the equation. So we have ax plus ab. Now we are making x the subject, so we don't need ab. So what do? We take the ab and then we bring it to the right side of the equation, because we are not interested in ab. What we are interested in is x. So we are going to bring all the terms that contain the x component, right? That is why here we move the ab to the right side. That is why we had bc minus ab. So once again, here is plus, so when it crosses it becomes minus, right? Now we are interested in making x the subject. So what do? We are going to factorize x out of this. So we have ax minus bx, right? Now since we are interested in making x the subject, meaning we want to make x to stand alone. We want to make x stand alone, right? So we're supposed to sort of bring out the x and then factorize it, right? So when you factorize the x, you're going to have x into bracket a minus b is equal to bc minus ab, right? Now when you expand this, you're going to get this thing, because when you expand, you're going to get x multiplying a giving you ax, and then x multiplying b giving you what? Minus bx. That is the same as this one, right? So that is factorization, alright? Okay, so after factorizing, we're going to get x into bracket a minus b is equal to bc minus ab. Now I want to make x stand alone, so because they are multiplying, x is multiplying a minus b. To eliminate a minus b, what do? We divide both sides by the a minus b, right? So that is what you are seeing. So we divided both sides by a minus b, right? So this a minus b will just cancel out the a minus b up here, leaving you with only x, right? So we are going to have x is equal to, you can decide to factorize this one too, okay? So b is here, right? So b into bracket c minus a, right? So you can refer to our lesson on factorization for a better understanding on how we factorize, right? Yeah, but then the basic concept is you bring out the common term or the common factor, that is b, and then you open the bracket and then ask yourself how many times will b divide bc, that is c times, right? And then ab, it is going to be only a, so you're going to have b into bracket c minus a all over a minus b, right? So it means that we have made x the subject here in this equation, right? So that is a simple process we are going to go through, right, in making any variable the subject, right? So let's delve deeper and look at other aspects. Okay, so let's look at a situation whereby we have fractions, right? So how do we dissolve the fractions, right? So we have to make a the subject in the expression 1 over x is equal to 1 over a plus 1 over b, right? So here the first thing we have to do is we have to find the LCM, and then we multiply through by the LCM. We are going to multiply each term by the LCM, right? Now, how do you get the LCM when you have variables? To get the LCM, it is simple. Just multiply each and every single denominator, right? So we are going to multiply x by a by b, and that gives us the LCM, right? So we are going to multiply through by the LCM so that we get a linear equation, a linear expression, right? So that is what we did here. So we are going to multiply 1 over x by abx, right? So we are going to have abx times 1 over x being equal to abx times 1 over a plus abx times 1 over b, right? So we are multiplying each expression or each term by the LCM. Afterwards, we are going to simplify, or we are going to cancel out, right? So with the expression on the left hand side, abx times 1 over x, now this x will eliminate this x here, leaving us with what? With ab. That's why you are seeing ab here. I believe you are getting it. When you come here to, we have abx times 1 over a. This a is going to cancel out this a here, leaving you with only bx. That is why you are seeing bx here. And then finally, this b here is going to eliminate this b here, leaving you with ax. So we are now going to have a linear equation, ab is equal to bx plus ac, right? So we have eliminated the fraction, and then we are going to use, or we are going to go through the usual process of making a variable the subject. So we are going to group all terms containing our potential subject, which is a. So ab is equal to bx plus ax. Now there is a here, there is a here. So we are going to migrate this ax to the left hand side of the equation, right? So this ax is going to transpose to the left side of the equation. So because it is plus, when it crosses, it will become negative, right? So we are going to have ab minus ax is equal to bx. And then as usual, we are going to factorize a out, right? So there's a here, there's a here. So we're going to bring a out, and then we open the bracket, and then we are going to divide. So how many times is a going to ab? That is b times, right? How many times is a going to ax? X times. So we're going to have a into bracket b minus x, all is equal to bx. And because we want to let a stand alone, what do? We divide both sides by the bx up here, right? We're going to divide the expression on the left hand side by b minus x so that it cancels out the b minus x up here, leaving us with only the a. And with an equation, whatever you do to the left side, you do same to the right side. So if you are dividing the left side by b minus x, we have to do likewise to the right side by dividing the right side by the same b minus x. So in the end, we are going to have a is equal to bx all over b minus x. So we have made a the subject successfully, right? So that is how we dissolve fractions. You find the LCM, you multiply through by the LCM, and then you simplify. You go through the same process, right? Okay, let's move on. Alright, so we have another question. So given that 2x plus ax plus 5 all over 4 is equal to x minus b over c plus d, and we have to express x in terms of a, b, c, and d. Now, this is another way of you being asked to make x the subject. So it is not all the time that you'll be given the traditional instruction, make x the subject in this equation or in this relation. No, sometimes you see express a variable in terms of other variables, meaning that let that variable stand alone. So you are seeing express x in terms of a, b, c, and d, meaning that when you look at this expression here, we have x, we have a, we have b, we have c, we have d, but then we are asking you to express x in terms of, meaning that in the end you are supposed to have x is equal to something, right? So x is equal to an expression that contains all these other variables, right? So this is another way of you being asked to make x the subject. Alright, so I just want to give you that clue that whenever you see it, don't think too deep. It is change of subject or make x the subject. Right? So let's look at how we solve this question. So like I told you earlier, for a fraction, or whenever you have a fraction, or let me say a denominator or denominators, what you do is that you find the LCM and then you multiply every term by the LCM so that your equation becomes linear, right? So here the LCM is 4c. So how do we get the 4c? We just multiply the 4 by the c here, right? So we're going to multiply each term by the 4c, right? We're going to have 4c times, now everything here is one term, okay? Everything here is one term, so we're going to have 4c multiplying 2x plus ax plus 5 all over 4 is equal to 4c multiplying x, this one is also a separate term, minus 4c times b over c, this is also a separate term, plus 4c times d, right? So that is what you are going to do. That is the first step, right? Then of course you are going to cancel out, right? So you are going to simplify. So 4 will cancel this for you, leaving you with just c. So for the left side of the equation, you are going to have c into bracket 2x plus ax plus 5. When you come to the right side, the first expression, you have 4c times x, right? 4c times x, giving you 4cx, right? When you come here to, you have 4c times b over c, so this c down here is going to eliminate or cancel out this c up here, leaving us with 4 and b. So that is that, okay? So you have 4b. Now when you come here to, you have 4c times d, so that gives us 4cd, right? So now the next thing is, now we've gotten a bracket, so we have a bracket here, so we have to expand the bracket, right? So in expand, you are going to multiply c by each and every single term inside the bracket. So it means c is going to multiply 2x, giving us 2xc, right? Or 2cx, right? C is also going to multiply ax, giving us acx. So c is also going to multiply 5, giving us 5c, right? And then you're going to repeat this expression up here, 4cx minus 4b plus 4cd, right? So the next thing is, we are supposed to group all expressions containing the x variable at one side, right? So we have 2xc, we have acx. Now we don't need this 5c because it has got nothing to do with x, so we just we just repatriate it to the right side of the equation, right? So it means this 5c will have to be transposed to the right side, right? And then there's x here, right? So 4cx. So we are going to carry everything. I'm going to move the 4cx to the left side of the equation. Because it is positive here, when it comes to the left side of the equation, it becomes minus. So we're going to have 2xc plus acx minus 4cx is equal to 4cd minus 4b minus 5c. Now I just interchange the position of these two. Okay, so I brought the 4cd first, then followed by minus 4b, and then accompanied by our immigrant, our 5c here. So because it was plus here, when it crosses it becomes minus, right? So now we have three different terms containing the x component. So what do? We factorize the x out, right? So since there's x here, there's x here, there's x here, we are going to bring x out, and then we open the bracket, and then we factorize. So we are going to have x into bracket 2c plus ac minus 4c is equal to 4cd minus 4b minus 5c. The next thing is divide both sides by the bracket, right? So that we eliminate the bracket, so that x stands alone. So that is what we did here. We divided both sides by 2c plus ad minus 4c, and we do same to the right side of the equation, right? So finally we are going to arrive at our x is equal to 4cd minus 4b minus 5c all over 2c plus ac minus 4c, right? Yeah, so that is how to deal with change of subject involving fraction. You can refer to our lesson on linear equations for a better understanding, because it is just an application of linear equation, right? Yeah, so let's move on. Okay, let's look at how we can dissolve squares, right? Squares. So let's look at this example. We have to make u the subject in the relation v squared is equal to u squared plus 2as, right? So let's begin. So it means that let u stand alone, right? Let u be at one side of the equation, and then the rest will be at the other side, right? See here, v squared is standing alone, right? But I want u to stand alone. Okay, so what do? Now there is u squared here, so this is u, right? This is u, there is u here, so you have u squared. So what we are going to do is we are going to move this 2as, right? Because it has got nothing to do with u, so we are going to move it to the left side of the equation, right? So we're going to have v squared minus 2as. Because it is plus, it becomes minus. So everything is equal to u squared. Now we were told to make u the subject, not u squared. So how do we eliminate this squared here, this exponent of 2 here? How do we do that? We do that by using the square root sign, the square root operation, right? So we are going to find the square root of both sides. So the moment square root encounters square, they cancel out, right? Yeah, they cancel out. So if you want to eliminate this square, you are going to find the square root of both sides. So you're going to have the square root of u squared, right, is equal to the square root of v squared minus 2as, right? And then this will just cancel out, or just take out this square root sign, leaving you with only u, right? So you have u standing alone, right? So being equal to v squared minus 2as. Now it doesn't necessarily matter if the subject is at the right side of the equation. And the equation, wherever the subject appears, doesn't matter. Whichever side it appears, doesn't matter. All we need is that let that variable stand alone, and that variable must be positive. Now if you decide to bring the u squared to the left side, it becomes negative, okay? Now let me show you an alternative method of solving this question. Okay, so you have v squared is equal to u squared plus 2as, right? So you see here, I maintain the u squared at the right side. Well, you may decide to bring the u squared to the left hand side because you are used to the subject being at the left hand side. In which case, you are going to have negative u squared, right? Because here it is positive. You're going to have negative u squared is equal to 2as. Then this one crosses and becomes negative v squared, right? So because you want to eliminate the squared, you're going to find the square root of both sides. And so you're going to have square root of u squared is equal to the square root of 2a squared minus v squared. So in the end, you're going to have negative u is equal to the square root of 2as minus v squared, right? Now, you were told to make u the subject, not negative u, right? So to eliminate this negative, so it means that the coefficient of this u is more of negative 1. Right, to eliminate it, you are going to divide both sides by negative 1, so that this negative u becomes positive u. Right, so when you do that, you're going to have negative u all over negative 1, and then the square root of 2as minus v squared all over negative 1. Alright, so you're going to have the u is equal to, now the moment you divide this expression by negative 1, you are going to interchange the position of these two terms, right? So it's going to be v squared minus 2as, the square root of v squared minus 2as, and that is the same answer we had here. That is the same answer we had here. Right. So that is how to dissolve squares. That's how to dissolve squares. Now let me give you this general principle as well. Now, if you want to eliminate a square, you use the square root. Now, assuming you had a cube, right? So assuming here were, let's say, v cube. If you want to eliminate a cube, you are going to use a cubic root, right? If you want to eliminate, assuming the power is 4, and you want to eliminate that power, you are going to use the fourth root. So depending on the kind of power, you are going to use the corresponding root, right? So if it is to the power 2, you are going to use the square root. If it's the power 3, you are going to use the cubic root. If it is the power 4, you are going to use the fourth root in that order, right? Okay, so let's proceed. Let's look at how to dissolve square roots. So let's take this question. We have to make Jane the subject of the relation t is equal to 2 pi and then the square root of L over Jane. So how do we eliminate the square root? Well, to eliminate the square root, we just use the square operation, right? So it is the opposite. When we wanted to eliminate the square, we use the square root. Likewise, when you want to eliminate the square root, you're going to use the square. Alright. So here the first thing is you are supposed to find the square of both sides. Right? Because what we want to make the subject is in the square root. It is caged inside the square root. So the first thing is you are supposed to square both sides. Right? Supposed to square both sides. So you're going to have t squared is equal to 2 pi the root of L over G all squared. So you're going to have t squared is equal to 2 pi all squared into bracket the root of L over G all squared. So when you expand, you're going to have t squared is equal to 4 pi squared. Right, now this square will affect the 2. It will also affect the pi. So 2 squared is 4. That is why you're seeing 4 here. And then pi squared times. Now this square root has been eliminated by the square here, leaving us with what was within the square root. That is L over G. So fast forward, you're going to multiply through by what? You're going to multiply through by the G. So the G will multiply the t squared, right? You're going to have t squared times G is equal to 4 pi squared L, because when you multiply this expression by G, the G will cancel out the G, right? So leaving us with 4 pi squared times this L here. So we want to make G the subject, right? So the next thing is divide both sides by the t squared, because we don't need a t squared, we need only the G to stand alone. So we're going to have t squared G all over t squared is equal to 4 pi square L all over t squared. So we have our G to be equal to 4 pi squared L all over t squared. Now you can decide to sort of further simplify this expression, right? So 4 pi squared all over t squared, you can decide to do it 2 pi all over t all squared, 2 pi over t all squared, and then you bring the L outside, right? Now when you expand this, you are going to get back 4 pi squared all over t squared, because this square is going to affect the expression up here as well as the expression down here. So it's going to be 2 squared, which is 4, and then pi squared all over t squared. That is the same thing we have here, right? So our G is equal to L into bracket 2 pi over t all squared, right? So that is how to dissolve or eliminate the square root. Alright, so let's look at substitution. Now there are times that after you being asked to make a variable the subject, you'll be asked to find the value of that variable given the values of the other variables. I believe you get it. So here we are given a relation here, a formula. E is equal to capital W into bracket capital R minus small r all over 2 times capital R times P. And you have to make R the subject in this equation or in this formula. And we are supposed to find the value of R correct to 3 significant figures. Given that R is equal to 12, that is small r is equal to 12, P is equal to 60, W is equal to 1024, and then our E is equal to 5 over 6. Right? So the first thing is to make R the subject. Subsequently, you are going to fix in or substitute these values into your relation to arrive at the value of capital R. So let's look at how to go about it. So the first thing is what? Is to make this capital R the subject. So let's do that one first. So because we are having a denominator, we are going to multiply through by this denominator. So we're going to have 2RP times E. Right, so this is a duplication. Let me just cancel it out. Let me just take it off. Yeah. Alright, so I'm going to have 2RP times E is equal to 2RP. Right, so this 2RP is also going to multiply this expression here. Right, so let me quickly add it here. Sorry for that. So I'm going to have times 2RP. Right, so times 2RP. Right. Okay. So this 2RP is going to cancel out this 2RP here. Right. So you're going to have 2RP times E giving you 2EPR is equal to W, capital W into bracket, capital R minus small r. Right. We're going to have 2EPR is equal to, you're going to expand the bracket here. You're going to have capital R times capital W minus small r times capital W. Now we want to make capital R the subject, so we are going to group all the R's at one side. So we have capital R at the right side of the equation. We are going to migrate it to the left side of the equation. Now we have 2EPR minus capital R W is equal to negative RW. Then we factorize the capital R out. So we're going to have r into bracket 2ep minus capital W, all is equal to negative small r and then capital W. So we want to make capital R the subject, so we divide both sides by 2ep minus W, right? So that gives us our R to be equal to negative small r W all over 2ep minus W. So this is the value of R, or let's say this is R made the subject here. So R is equal to capital R is equal to negative small r W all over 2ep minus W. Now the next thing is to substitute these values into the equation to find the value of R, right? So given that R is equal to 12, so now wherever we see small r, we are going to put 12 there. Wherever we see P, we are going to insert 60. Wherever we see W, we are going to replace it with what? 1024. And wherever we see E, we are going to replace it with what? 5 over 6. So that is what we did here. So we are going to have R is equal to negative 12 times 1024 all over 2 times 5 over 6 times 60, because E is 5 over 6, so 2 times 5 over 6, and then P is 60, right? So times 60 minus W, that is 1024. So 12 times 1024 gives us 12,288. Now 2 times 5 over 6 times 60 gives us 100, and then minus 1024. So 100 minus 1024 gives us negative 924. So we're going to have negative 12,288 divided by negative 924. And when you punch on your calculator, you're going to get approximately 13.299. And in three significant figures, you're going to have 13.3. 13.3. So our R is equal to 13.3. Right. So that is how to go about substitution. So after making a particular variable the subject, you can be asked to find the exact value given the values of the other variables. So you just have to replace the given values in the equation to arrive at your answer, right? So this is what we bring this lesson to an end.